lesson is solving a system of equations using substitution. When you have two equations given to you, you're looking for a value for x and y that will make both equations true. So for this method today, we're going to solve by substitution. My first equation is 6x plus 7y equals 20. And my second one in the system of equations, these two are tied together, is equal to 2x. So to solve by substitution, you are looking for the variable that has a 1 as a coefficient. So in my second equation, I see that for my y. So when I'm looking at this, I am going to take this second equation where y is equal to 2x, and wherever I see a y in the first equation, I'm going to substitute in 2x so I can solve for x. So let's go ahead and I'm going to copy the first equation down below so I have it right in front of me. I am underlining my y because I know that's where I'm substituting in my 2x right there. So it is going to be 6x plus 7 on the outside of my parentheses. I'm plugging in my 2x. And remember, when it's written beside each other, that means we're going to multiply. So that is right now where I stand. Of course, now I need to simplify and solve for x. So 6x plus 7 times 2 is 14x is equal to 20. And notice, I am now going to add my x's together. So I end up with 20x is equal to 20. And last step, we know from multiplication, the inverse is division. So x is equal to a 1. And right up here, I like to start my ordered pair for my answer because you will be an ordered pair. For every x, there will be one y value and only one y value for the problems that we'll be working today. So now I'm going to go ahead and I get to decide which original equation, do I want to put my 1 in to go ahead and find the value of y. Well, I think the second one would be easier. So I'm just going to copy y is equal to 2x. I'm going to say y is equal to, and now I'm substituting my 1 in for my x. So y is equal to 2. The ordered pair of 1, 2 will make both of these equations true. So let's go to one that's a little bit more complicated. For the first one, it actually gave us y was equal to 2x. Look at the second problem. As we look at this, we can see we have x plus 3y equals 1, and negative 3x minus 3y equals a negative 15. A lot of negatives. We're going to have to be careful today. But I see that my x up here has a 1 as a coefficient. So I know that my first equation is the equation that I am going to go ahead and write so that I have x is equal to something. So let me recopy that, and I have x plus 3y equals 1. In order to get x by itself, I am going to subtract my 3y, and it doesn't matter whether you put it in front or behind the number. I'm just going to put it behind the number. So I end up with 1 minus 3y. So notice that is my x value. So I'm underlining that x, and I know I am going to substitute in wherever I see an x in this equation up here, I will substitute in 1 minus 3y. All right, so now let's go ahead and let's solve this equation that we have. We have a negative 3x minus 3y equals a negative 15. When I'm recopying it, I always double check to make sure I've copied it right, because if I leave out a subtraction sign or a negative sign, it throws my whole answer off. So now I do know that where I see my x, I am going to put in my 1 minus 3y. So here I have my negative x times the quantity 1 minus 3y minus the 3y that is already there equals negative 15. Remember the distributive property, we're going to multiply both, and I just go ahead. I always think of this is a negative 3, and I attach the sign to the second part. So I think of the 3y as a negative 3y. When I'm doing my multiplication, negative 3 times 1 is negative 3. A negative 3 times a negative 3 is a positive 9, and that is a y, minus 3y equals a negative 15. Again, I just copied everything. Now we're just going to solve the equation like we know how to do. You're an expert by now by solving equations if you're solving a system of equations. So I'm going to put those y's together, and I get a negative 3 plus a 6y equals a negative 15. All right, I'm going to add 3 to each side to get the number on the other side of that equation, and I end up with 6y is equal to a negative 12. Last but not least, we need to divide by 6, so y is equal to a negative 2. Again, I like to go up. I like to write my ordered pair, and I have this time my y is a negative 2. So now I need to find x. I can use either one of the original equations, but the first one seems so much easier to me. So I am going to, again, copy the first equation down. X plus 3y equals 1. We don't have to write the 1 there. It's understood. So now x plus 3, remember y was a negative 2, is equal to 1. And now I'm going to multiply that out. So x, it's plus 3 times negative 2, a positive. I think I catch this in the front. So that is a negative 6 is equal to 1. And finally, the last step, I'm moving my 6 to the other side of the equation. So x is equal to 7. Only ordered pair that would make both of these equations true is the ordered pair where x is 7 and y is a negative 2. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.